All right, hi guys. 2019 higher level question 5 here today to work through. Sorry, it shouldn't be question 5, it should be question 1's written up there. Okay, I'll obviously have to fix that. But anyway, question 1, orthographic projection every year is the same question. You're asked to draw plan, elevation and end view, and usually determine the true shape of some surface. So what I have done, and I have attached this to your download on Google Classroom as well, is I have pre-printed some of the solution already, the bits that you can already do, the bits that I know that you're okay for. And I'm going to work through the couple of difficult bits that are in this question. Just to be sure though, I'm going to back over how you would set this up and how you would go about doing this question anyway, just in case there's any of you unsure as to how to get to that point. Okay, so we are given, so this was last year, pictorial view. Pictorial view, we know, means 3D view. So we're given a 3D picture of a mobile lunar camera, and it's shown in the figure. So figure 1 down here, and also shown as a 3D graphic of the camera. So there's my 3D graphic. And I pulled this out of the solutions as well to help you. But that wouldn't have been given to you. Only what's inside in the box is what's given to you in the exam. Part A asks us to draw an elevation in the direction of arrow A, which is over here, so that's my elevation. B is project a plan from that elevation. And C, project an end view in the direction of arrow B. So an end view in that direction, arrow B. Okay, and then we're asked to determine the true shape of surface S. Okay, I'm actually going to go through this as if this was our first time ever doing orthographic. So I'm going to do it fairly quickly, but I am going to remind you of something that we did when we were in first year, which was shading. And it was, I got you, particularly with the easier questions, to start at the start of the question and take the 3D model and shade it, but shade it from the aspect of, well, where am I when I'm looking at this object? What view am I seeing? What am I seeing if I stand at a particular arrow, etc. So for example, if I start over here with arrow A, okay, and I call her arrow A in red, and I say to myself, right, I'm standing there, I'm looking in at this little machine thing, lunar camera, mobile. What would I see, or what would I have a view of from that side? Well, straight away, the nearest thing to the arrow is I would see the surface here. So I'm going to shade that in red. I would also then, as I look in at it, see this surface here. Now just be careful, I'm going to shade any surface that I will only see in the direction of arrow A, because there's a few that will overlap, and I'll come to them in a minute. So to start with, I will see this curve, but I need to be careful because I'll only see it really as far as there. I will see some of this pipe, I don't know, what would you call it? This yoke, all right, I'll see some of this yoke. Okay. I will also see a little bit of surface S, but not a little bit, I will see it full stop, but I also see that in another view. So I'm literally only concentrating at the moment on what I see only from arrow A. And, oh wait, a little bit of a curve here that will be seen as well. So I will see that curve in as far as there. So that's arrow A taken care of for the moment. Then it said a plan from the elevation. I'm going to go with the green color for the plan. So what do I see looking down? Because that's what a plan is. The plans of a house. It's what you see when you look down into it. What to see when the bird flies over. So he will see, or you will see if you were looking down from above, this top surface up here. I will see this surface over here. And I will see this surface here, and the one at the back as well, of course, to match it, which you can't really see in this picture, but this is a symmetrical object. It appears front and back, so I'll see it there. Now I am beginning to overlap a little bit, because you would see this surface, and I'm going to mix the two colors, so to speak, where they overlap. So in other words, I'm going to see this tubing, tunnel, I don't know, what would you call it, pipe, in both views, so therefore it gets both colors. And for the moment, I'm just going to leave that one like that. Now, if I stand at arrow B now, which is going to be my end view. So arrow B is the end view. Okay, so what will I see from arrow B? Okay, so I will see the surface, this section here. I will also see this surface. So again, trying to stick with the simpler surfaces, the simpler edges. And there's a little teeny tiny bit of it just there. I will see a little bit, and again, this is here where we're going into overlap again. I will see this surface there, so the blue and the green are overlapping. I'm not too worried about that. If you remember when we did these in first year, it was a lot simpler to do them because you didn't really have, certainly at the start of this topic, overlapping sections like we have there. I will see this edge here. No bother, and the corresponding one at the other side. I will also see this surface, and again we're into a bit of an overlap, so this time it's red and blue overlapping. Now, why is there an overlap? It's because the shape is visible from two views. This is also slightly visible there too, that little section. Now, there's a couple of bits there that I haven't coloured in, and this is why colouring in is a good idea. The slope section I haven't coloured in, and technically that will be viewable from both arrow, not the top of the plan, and from arrow B because it's visible on both surfaces. But I'm actually in this situation going to give it a different colour entirely, and I'm going to treat it slightly differently. So it would be a bit of green mixed with blue, but I'm just going to put this purpley colour on it, because I'm going to treat it slightly differently. It's a little bit trickier, it's a little bit more involved, and I just, when I get to that stage, need to stop and think about it for a minute. And then the last piece, and it is quite an important section, we were asked to determine the true shape of surface S. There's surface S. Now I'm actually going to put it in surface S, even though I've shaded the rest of it. I'm going to put surface S kind of nice and heavy. I want to make it fairly obvious. Now, okay, would you have time for all that shading in an exam? No. But if you're used to doing it, you will be able to manage the thought process inside the exam and be able to get going on that question fairly quickly. Now, not ready to start yet, mind you. Because if you remember when we did these in the classroom, you will remember me drawing a little picture of and this is why I've left space over here. We're asked to draw a plan, an elevation, and an end view. Okay, so I'm just going to lay out my sheet for a minute because this is already done for you on the one I've given you. Now, back to basics. So that's my sheet, my drawing sheet. Okay, ready to go. A little bit of tape up there even. Tape up there just so you know what it is. Okay, leave your name and date and all on. So when we're doing orthographic projection, you are always going to draw an XY line. You're always going to put in a vertical XY line, or vertical YY line actually. And then you're going to have to stop and say, well, which one goes where? And if you remember back what I said to you, and I said, look, this is the way we're going to work it all the time. I said, whatever direction the arrow is pointing in, it's pointing to the side that you put that view. So for example, arrow A is pointing to the left. That means the shape for arrow A, or the view from arrow A, is going to be on the left hand side because it's pointing to the left. Arrow B then is pointing to the right, so B is going to be over here, and they have wanted us to do a plan from the elevation. A is my elevation, so there's my plan. Okay, which means for us, and for the method we've always used, my 45-degree line is going to go down there. Okay, and you always need to work that out, and it's, look, a quick drawing does it in a couple of seconds and you're not going to make a mistake. Okay, next thing that I have to figure out, or have to remind myself, is ideally I want to draw a rectangle in for arrow A. In other words, the widest part of arrow A and the tallest point of arrow A, what I see when I look in the direction of arrow A. So before I ever start, when I get my fresh sheet, I'll put in my XY line and my YY line, I'll put my 45-degree line, and I know my arrow A is going there, or my view from arrow A is going there, and what I'll do then is I'll box it off, frame it, and say, right, that's the box that my object is going to sit into, and it's not going to go around it. It helps just kind of keep all your drawing together, keep your head going as well. And I will also then say, well, the plan, I'll box it off as well. What would that look like? Well, there'll be a little gap between the plan and the elevation. And again, same story. What size box would it fit into? What's the widest measurement? What's the tallest measurement? Okay. And then you know when you're doing right, when you don't have to measure anything for arrow B. Because arrow B then just sort of appears because of the topic we're doing, orthographic projection. Projection means project shapes, measurements, heights, distances. Move them, project them over into a view. Okay, so that's now the layout. So I've prepared my colors, I've prepared my layout. Just, I suppose, arrow A in this case is going to be mostly this color. So I'm just going to shade in the color just to remind myself. Arrow B is going to be the green, isn't it? Oh, sorry, not arrow B. Arrow B is, sorry, the plan is going to be the green. And B is going to be the blue. B for blue. Okay. So now I know where I'm going. And I'm asked for plan, view from above. So, a few notes here. Is always, a plan is always a view from above. And it always goes under the elevation. Now, mind you, an end view is an end elevation as well, and it could often go under the end view too. It's one and the same. But anyway, so far, plan is always a view from above. So anything else there that came up? Good idea to shade. Yeah, that's enough for now. I'll be coming back and adding more to that now later on. All right, so looking at the sheet then that I already have printed out, I'm going to add a little bit of detail to this because, yeah, okay, it's all there. But sometimes when you look at the solutions, it's hard to pick out. Now, remember, this isn't a finished solution. This is partially done, even though I haven't got rid of a hell of a lot of it. But what I am going to do is heavy in the XY line. And I know I've said this to you in class, but I'm going to say it again now. Always, always, always put in a nice heavy XY line. When it comes to 5th year and you're doing far more complicated orthographic projections and far more complicated questions, the fact that's a heavy line will save you. Because what happens is if you leave it too light, your brain doesn't distinguish between the views. It thinks it's all one item. And yeah, of course, it is all one item. But we need to think of them as 3 separate views in order to deal with them. And in 5th year, if you do take on DCG, you will have not only 3 views, but you will have more views off the same view. You'll have auxiliary views, which you've heard of before and didn't particularly like. So one way to get around that is make that line nice and heavy and make it stand out. In fact, well, I can't really put a YY line in here now because of the way they've it drawn, but it would go up there. All right, just a little bit of revision while I'm here, while I'm looking at it. Let's watch how the circles, for example, or the surfaces were put in. Let me pick a point, any point. Okay, so for example, the wheels of the tracks, or the, I don't know what they're called. What happens from plan? Plan moves over to the end view. It's projected up into the end view and projected across from the elevation. And that is how that point, for example, ended up in the end view. Orthographic projection. Okay, you are projecting lines in order to generate shapes and generate views. Okay, so that's that covered. We know that anyway. Take, for example, the center of this circle. By right, I should see, I'm going to do this with my pencil. I should see that center line brought across the elevation. I'm going to need it here. It's already brought over here in plan, so that's good. So that's okay. I'll take that. Okay. And of course that matches up with this line here. Now, if you were in any way unsure about how to draw these, I'd prefer you to start from scratch and draw the plan, elevation and end view, not the printed one that I've given you. Okay, yes, use the one I've given you to help, but you need to start from scratch. Some of you will need to start from scratch in order to kind of learn this and get used to doing it again. The other thing too is if you are drawing it from scratch, if you're drawing it full size and you have A3 sheets, look, that's great. But some of you won't have A3 sheets, and you can still do it on an A4 sheet, you just half the size, divide every measurement by 2. That'll work out fine for you. I checked that even earlier on here. Okay, so just putting in a few more little bits, little details that aren't there. A lot of the time when you look at the solutions on the examinations.ie, yeah, the answer is there, but the working of that answer, or sometimes it's hard to understand where they got parts from. And maybe one way of doing that too, if you're stuck as well, is to sit down and print it out and draw over it. It's a way of learning. Remember, in TG, you're not learning unless you're doing. All right, so that's my plan elevation and in view. Now, I was going to shade it in at this stage, but I'm not, because I don't want to clutter the drawing, I suppose, a bit. Not yet anyway. What I will shade in, all right, is surface S, which has gone in there. And I need to mention at this point, or at this stage, because I'm about to use the word point separately now again, I need to mention at this stage that this point up here at the top, well, where do you get it from? Okay, and I just want to point out that in the question, is that on the camera? It is. It is 70 millimeters along this edge here. Let me zoom in a bit on that. Okay. So it is 70 millimeters from this corner to the edge, so 70. Which means it's 70 in elevation. So this 70, I'm trying to figure out where I should write this, only appears in elevation, or only can be drawn in elevation, in ELEV. What do I mean by that? I mean, right, that when they were putting together this elevation here, okay, let me zoom out a wee bit again. Okay, so when they were putting together this elevation here, they knew where that corner point was, right? They had that, they had all the measurements for that. And they knew where this line was across here. So there was a light line cutting across through the object just like that. So they knew that. But what they didn't know is where this line was. And the only way they had of finding it, and I'm going to have to work backwards a little bit here, is they set their compass to the 70 millimeters. They couldn't measure it down here. And actually, I want to show you there quite clearly it's not the same measurement. They certainly couldn't measure it over here. So what they had to do was swing an arc just there. And that's what gave them that 70 millimeter line. And more importantly, I suppose far more importantly really, it gave them the line in plan. So you would not have been able to draw this line in plan without swinging that arc at that stage. So an arrow on there, it's going down. Okay. So that's one little tricky bit. So that was one little extra bit there. So the radius there, and let's mark it in so that we know if we ever come across it again. I'm actually going to make the arc a bit heavier. Okay. I'm doing this for explanation purposes, not necessarily draftsmanship purposes, but there it is, right? And that arc has a radius of 70 millimeters. Okay, now, the other thing that you may have found tricky or would have found tricky, and it's the bit I've left out, is how do you do this curve? If a curve meets a slope, an ellipse is going to be generated. So what do you have to do? Well, you have to go look and check and find and locate where in that question is the circle seen as a circle. Okay, you need to see which view shows you the circle as a circle. Okay, and on my one, that is over here in your end view, and it will be in yours too. So I go over to the end view and I divide up my circle into 30, 60 degrees. You have done this so many times in class. And why 30, 60? Well, just to give yourself some points. You could use any angle you wanted really, but we don't need any more than 3 points. What do you do after that? Then you say, well, right, what happens? This tube or this tunnel, I don't know what you'd call it, camera lens maybe. Anyway, moves in along, or at least it has a certain thickness and it stays that thickness, and it is circular, and eventually it reaches this surface. And when it reaches that surface, and actually, you know, it's not rocket science here, when it reaches that surface, it becomes an ellipse. And you can actually see that in the 3D view. I can see it here, I can see it here. Yes, I can see it there too, but bear in mind that view up there on the top right wouldn't have been given to you in the exam, but there it is, look. So it's meeting that surface. So I know it's meeting that surface. I know there's going to be an ellipse. So the second thing I have to look for, so step 1 is find where is the circle. And there it is in the end view. Step 2 is figure out where is it as a line. And that edge, that purple edge that I had in the original question, that I had on my question sheet, there it is appearing as a line. And that line meets the tubey bit somewhere along there, or meets it at various points along there. So what I say to myself then is, right, okay, there it is as a circle, there it is as a line. What do I need to do? I need to put those points on the tube. So imagine they're drawn like stripes down the side of the tube. So for example, if I take this guy here, okay, look, there it is. There's the stripe down the side of the tube, okay? If I take this one, actually I'll just do one first, not to confuse the issue. I'm going to just call that point 1 for a minute, and we're just going to work through that one. So point 1, okay? So it comes over, it hits the edge of the surface, but I am not done yet, because I have to bring that point 1, okay, which is now here as well, point number 1. I have to bring point 1 down to plan, because that's what we are doing over and over again. We are projecting. So point 1 goes down. Don't know how far down, only that I can kind of see it because the way I printed it. But I do the same thing from the end view. So basically I'm doing what I did earlier on, which is moving from plan and elevation to end view. I'm doing that again, but in the opposite direction. So I'm moving from end view and plan, sorry, from end view and elevation to plan. So if I bring down the end view, where do I end up? Oh, I end up down there. Bring it over. And look at that. We have point 1 on that little ellipse. So there's number 1. If I do the same thing with number 2, now I'm going to use a different color now because I want you to try and visualize it separately. So number 2, same thing, over. I visualize it as a stripe. I don't even need the line that long, to be fair, but I really want you to be able to see what I'm talking about. So there's point 2, and there's point 2. What happens at point 2? Well, it gets brought down to plan, just like that. It gets also brought down from the end view, just like that, and over. And again, where it crosses is my point number 2. Now, put arrows on that to remind you of which direction we're going in. So we were starting there, so that one went that way, hit the edge and came down. This guy went this way, hit the 45-degree and came across. And so did the blue. Now, why have I only done 2 points? Well, it's symmetrical. It's identical to both sides. So why bother bringing down 2 more points that are on not quite the same lines, but two of the same lines, and going to the bother bringing them over when you can just reflect the points through. So that's what I'm going to do right now. I'm just going to reflect the points through and use my compass on it. Yellow, I suppose, yeah. So point goes through the line out the other side, same distance. So back to axial symmetry, lads. Sound familiar? Where's my compass? Oh yeah. So there to point 2. I hope my hand isn't in the way. I think it is. Reflect it over. There's point 2 at the other side. And look, 1 is so small, I'm actually just going to measure it. So almost 6 millimeters, just there. So point 1, point 2, and there. Symmetries. Now, the only one I haven't done there is, and we always need to find it, is the end point of the line. In other words, the very top point. I haven't dealt with the top point. So the top point in this case is just here. So what do I do with it? Same story. Over. The only difference is that here it hits right there at the edge. Over. Down. And down and across, and all is well with the world, because there's my next point. And of course, and don't forget it, to finish it, this is where I need to get up off my stool, sketch in the ellipse, bearing in mind that no ellipse has a point. They're all curved in towards the edge. Get it as smooth as you can. However, don't spend ages on it, and I'm dying to spend ages on it now because it's looking a bit rough. But okay, you know how is the important one. So there it is. Did I leave anything out of there? Yes, actually, I should have shown you this point as well. So that'll be the outermost point. Which would have been just bringing down that point, bring it over, bring it across, we'll cut there. So that's all, that's nothing major. All right, now the last bit, and the bit that, and we did this question in class before, but the bit that every time in class we get towards the end of the class when you're getting tired, it's always the hard bit is left last. And here we are again with the hard bit, but however, because we had this drawn, you shouldn't be too tired or too unable to do this, and certainly should not leave it out. Now, here's what I'm going to do. Okay, I'm going to go back to brass tacks, which is what I told you day one. When you're asked to draw or to sketch, or not even sketch, sorry. When you're asked to draw the true shape of something, what I want you to do every time is try and colour in that shape in every view. So I've already coloured it in elevation. If I go over here to the end view, surface S in the end view is right there. Okay. So if I was to shade it in, I'd be shading down along here. And I'm also shading over my lines. But anyway, they're the ones over there since the start, so they're not terribly important. Okay. And if I go down to plan, oh sugar, I can't shade it in. And why can't I shade it in? Because if it was a wall or an edge and I had painted it yellow, the bird flying over the object would not see any yellow, because the yellow would be running along. The thin layer of paint would be running along the edge just there. Okay, and now you're sucking diesel, because that's the one you're interested in. So this is back to, remember inside in G26, I'd stand at the top of the room and I'd open and close the door and I'd ask you, when do you see its true shape? And I'd twist it and turn it and I'd say to you, look, the more you turn it and the more you tilt it towards yourself, the more likely you are to see the true shape. We're going to do the same thing here. I want you to imagine for a minute that this, I know they're calling it a lunar camera, but to me it looks a bit like a tank, right? Imagine there's people inside that tank and this is the door and this is the door they need to get out of, right? So if they were to open that door could hinge off any one of the surfaces. But the easiest one it is to hinge off would, or the easiest two, would be these two vertical lines, the vertical line on the left and the vertical line on the right. Now, why am I interested in hinging a door at all? Because I'm going to turn it so we're looking straight at it. The problem at the moment, and this is probably the hardest thing to understand, I could show you 100 times over how to draw this, but understanding it, we're in a different realm here. You are standing there when you see it in elevation. The person is standing looking straight at it. But unless you are standing at 90 degrees to the line, you are not seeing the true shape. And at the moment, we're not standing where my pencil is pointing. We are here looking straight in. So what I'm going to do is I'm going to say, right, what if I put a hinge on that line, right? And I put the hinge just there. And I say to myself, right, the lads are going to try and get out of here. The lads inside the imaginary tank that I've now created in my head. Now, you know I'm still mad, lads. At least you haven't seen me in a few weeks, but you know I'm still mad. But anyway, they're trying to get out of here. There's my hinge. What actually happens is some lad comes along, opens the door, pushes the door, and the door rotates in the hinge. Where do I want it to rotate to though? I want it to rotate until it is a horizontal line, but more importantly, 90 degrees to the person looking at it. So in other words, the door is going to hinge open and swing open to there. Now, I have told you this, I don't know how many times before, but I'm going to say it again. If you're opening a door or you're opening an edge, you're twisting an edge like that, when it turns, it's going to turn on a circle. It's not going to get smaller, it's not going to get wider. I gave you an analogy one time about it. Well, if there was carpet on the floor of our drawing room, and if the carpet was too high and the door kept rubbing off the carpet every time it opened, it wouldn't be long before we had a mark in the carpet that was semicircular. Okay, because the door would make an arc every time it opened. So that's what we have to do now. So I'm just setting my compass to the length of the yellow door. Trying to get it accurate. There it is. Okay, and what happens to the door? It starts here and it swings open. Just like that. Now my compass is a bit funny, so I just need to make it a bit harder. Why does the compass always move when you don't want it to? There it is. Now, bit of a messy arc. I don't like that arc, but anyway, there it is. So what happens anyway? The door opens as far as there. So now, where's my door now? That's it. Okay, so we have swung it open. God, that arc is awful. Please excuse the state of the arc. Because I haven't compass leads nor the ability to get them. Okay, so anyway, it opens as far as here. Whereas here, it's on a line that is horizontal. Look, T-square line, horizontal line. Now, so if the door is fully open, I should be careful here that I don't go off the edge of the video. If the door is fully open, what happens? I project that up to elevation. So door gets projected up. So there's the hinge. Project up to elevation. Now, you and I both know, and I hope you remember, that every time a door opens, it neither rises up nor closes down. It doesn't go up or down. Its height doesn't change. Heights do not change. So the height of the door is still the same. So what actually happens to that door is, yes, it swings out and swings open, but the points that are on the door move across into the new position. Okay, now this one doesn't move because it's on the hinge, but everyone else does. And as a result, my door and my surface S, let's go back to what they're actually asking us for in the first place, in its true shape appears right here. Now remember what I said when we were talking about true shapes in the early days. I said they will always be a similar shape to the original. So this will still look like surface S, but usually it's a fatter version, a wider version. It is the widest it can be. It is the true shape. So surface S, what do we do again? Swung it out, brought it up. Okay, brought it up. Brought these guys across to meet. So we're going that way in terms of arrows, and that way. And as soon as it hit that side, there was my true shape, TS, true shape. So, and don't forget to notice true shape. Of surface S. Okay, and where actually is that? It is there. Okay, and there's my finished question. Part A, plan, elevation, and end view. A, elevation. Part B, plan. Part C, project and end view. And D, determine the true shape. Yes, it's laid out as I had wanted to lay it out. So where am I? Up here. Okay, so it's laid out in the same way as they had requested, A, B, and C. Plan was always a view from the above. True shape. is always found by searching the 3 views, looking for the one view where it appears as a line. In other words, the one view where you cannot shade it in. Projecting envy in the direction of arrow B, did all that. Yeah, we're done. Okay, so there will be 70 marks for that. Keep in mind neatness, tidiness, accuracy, all of that. And also, I'm going to go ahead now, and before I finish the video, I'm just going to add some of the titling and the shading and so on. Okay. Okay, so there we go. Shape, surface S is done. Plan, elevation, end view is done. I've shaded them in, mainly to show you again, or supposed to remind you how, when it's in a 3D view, how it looks like it's multicolored. And yeah, it is multicolored, but when you start breaking it down into its 3 views, essentially the plan is mostly green, elevation is mostly red, and the end view is mostly blue, bar the surface S, which I wanted to extract separately anyway and talk about differently, and that purple surface as well, this sloping surface at the front. Now, while I was shading it, it occurred to me that this here, where we went with the radius 70, this was kind of similar to what we were doing with the true shape of surface S. The difference here was that radius 70 was a true length, and the true length was only seen where we saw the surface, in other words, that purple surface, as an edge view. And there it is, an edge view. This is also an edge view of surface S, which I didn't use that terminology at the time, but that's what it was. In other words, where you can only see along the edge. Makes sense? Where you can see along the edge, edge view. So yeah, that's that one done. I will post the video, and on Google Classroom, you'll find the printouts. All right, thanks guys. Best of luck.